Let's wrap up this week with one more quick feature for polymorphism: pure virtual functions. Looking back at our shapes example, our shape class provides its own implementation for the area function. While this is kind of weird since it doesn't actually give us the area of any real shape, it's also an opportunity for a bug. See, any of our specific shape classes, like circle, could omit their area function and our example would still compile and run happily. Every circle object would now just be using shape's implementation of area. Thus, every circle would tell us that its area is 0. What we really want is for every specific shape class to be forced to provide its own implementation for area. We'd like to get rid of this nonsense default implementation that doesn't do anything useful. This is what pure virtual functions do. A pure virtual function is a virtual function that is declared but has no definition. As a reminder, a virtual function is just a function that can be overridden by derived classes. How do we convert a virtual function into a pure virtual function? Well, all we need to do is replace the body of our function with equals 0. This tells us that every class derived from shape must have an area function, and there's no default implementation for anyone to fall back on. Now, all of our classes here do have an area function, so our program's behavior hasn't changed. What happens if we remove the area function from one of them? We get a compiler error. This error is telling us that it can't create an instance of the circle class because circle is an abstract class. An abstract class is any class that has pure virtual functions that haven't been overridden. In this case, we can see the pure virtual function causing the problem in the error notes. And sure enough, it's the area function that we removed. Pure virtual functions are a great way for us to define and enforce a common interface for other class types. They tell us that a function is available, but avoid the risks associated with creating a potentially nonsensical default implementation. And that's it for the C++ track for this week. I know this has been a pretty heavy week, so take some time to play with the tools we've introduced and make sure you're comfortable with them. But with that, I'll see you next time.